Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about hierarchical clustering. Hierarchical clustering is an example of unsupervised learning. The various topics that we are going to cover today are introduction about hierarchical clustering. Why do we need to have an hierarchical clustering? Why not we solve all the clustering problems using K-means algorithm? What is the exact reason for using the hierarchical clustering? What are all the scenarios where K-means algorithm is not suitable, and why do we need hierarchical clustering? The different types of hierarchical clustering. There are two types of hierarchical clustering. What are they? What are all the steps involved in each of those two types of hierarchical clustering? And we will be going through a simple example and see how the different steps in hierarchical clustering would work on a real small data set. Like as we progress, how do the data transform? How do we identify the different clusters? And we will be going through like the technique that is used to identify the ideal number of clusters. So in case of K-means algorithm, we had a method called an elbow method. So in case of hierarchical clustering, how do we come up with the ideal number of clusters and how does it work? And some of the key terminologies that are specific to hierarchical clustering that would be required for you maybe in terms of interview or to just understand the concept of hierarchical clustering better, and the advantages and disadvantages of using the hierarchical clustering. So these are all the topics that we will be covering today, and in the next session we will be going through a simple implementation based on a real data set and simple implementation of hierarchical clustering using a real title data set. So that's what we are going to do for today as well as in the next session, and we are going to do all these in order to learn the hierarchical clustering and where it can be utilized. So let's directly jump into the topic and let's see what it is. So as you see on my screen, first, like hierarchical clustering is a classic example of unsupervised learning, which means that the dataset that we have is unlabeled. So this is an example that is typically used in order to solve customer segmentation. So let's say we have a different profile information of all the customers. So it could be anything. It could be an e-commerce, it could be an energy retailer, it could be a telecom company. They have the profile information of all their customers and they want to group the customers together based on the similar patterns or similar behaviors. So what we do, we don't have any labels based on the profile information. We use clustering algorithm to identify the different clusters, like the group of customers who are similar to each other. So what we can do, we can launch a marketing campaign to all those customers as a group. So this is the purpose. Like this is a common example where a clustering algorithm would be used. The observations in the data set are grouped into, so in case of hierarchical clustering, what happens is the observations in the data set are grouped into different clusters based on the sequence or based on a hierarchy in the data set. So that's where the hierarchical clustering comes into the picture. In case of K-means, what we do is we use the distance method and group them into small clusters based on like how close they are to each other. Whereas in case of hierarchical clustering, we use a sequence or a hierarchy in order to come up with the clusters. The same data set, like if we have a customer profile data set, like it can be solved by using both K-means as well as hierarchy, but how we implement it differs a lot. The methodology is very different and hence the results could be very different as well. Coming to the next point, that here in this case, the objective for us is to group all the similar observations together. So let's say if we have a list of customers, the objective would be to group all the similar customers into a particular group. That is the objective of any clustering algorithm. So here in case of hierarchical clustering as well, the objective is to group all similar observations into one single group. The next one is hierarchical clustering can be built based on a distance matrix. So whatever data set that you have, so if it is a distance matrix, it's very easy. You can directly implement an hierarchical clustering on top of the distance matrix. If you don't have a distance matrix, so the raw data set needs to be converted into a distance matrix. So we can use any specific method in order to identify the distance between each of those observations, and the distance matrix is the input that needs to be passed on to the hierarchical clustering algorithm. So that's an important point. So what is hierarchical clustering? So if you maybe want to compare hierarchical clustering, you can compare it with the files and folders in your hard drive. So all the files will be in a specific folders, and some of the folders will be within another folder, and that will be a tree-like structure. Similar to that, the hierarchical clustering output will also represent a tree-like structure. So we are going to see today the implementation and how the tree-like structure would actually look in case of hierarchical clustering. And coming to the different types of hierarchical clustering, the two different types are agglomerative as well as divisive. These are the two types of hierarchical clustering. We are going to see about each one of them in detail. So before going into those details of different types of hierarchical clustering, the first question is, why do we need to have an hierarchical clustering? For example, we have Terminologies algorithm, which is quite good in identifying the different observations that are similar to each other. It will be good enough to identify different clusters that is present in the data. But why do we need to have an hierarchical clustering? So the number one reason is, in case of Terminologies algorithm, what we need to have the K value. We need to have the number of clusters upfront before progressing. So which is a critical input. In some cases, what might happen is the dataset might not reveal an ideal K value. The dataset will be such that there is no ideal K value, and hence it is not feasible for us to keep trying different K values and then see how the outputs would look like. Depending upon, let's say we pass 2 as a value for K, the algorithm will be able to come up with 2 clusters. But is it the right one? So maybe should we try 3 or should we try 4? So there is no answer to it. Depending upon whatever input we pass, we get so many different clusters. But is it the ideal number of clusters? So we don't have an answer for it when the data set doesn't exhibit any kind of ideal K value. So in those cases, what happens is an hierarchical clustering would be a better option. The next one is, so generally in case of Terminologies algorithm, it is an iterative process. So the iteration continues until the centroids of those clusters doesn't change. So what happens is, in Terminologies algorithm, once we identify the different clusters, the centroid would try to keep realigning themselves depending upon the data set. So we stop when the maximum threshold has reached, we set the maximum number of iteration that the algorithm can go through. Or what happens is, when the centroid for those clusters doesn't change on an subsequent iteration. So when that happens, what we do is we stop right there and then we identify the different clusters. So this is an iterative process. In some data set, what might happen is this process can continue for too long. Whereas in case of hierarchical clustering, what happens is, if we have n number of observations, the number of iterations that we go through cannot be more than n. So at max, what it can happen is, it can go through the number of iteration would be equal to the number of observations in the data set, and definitely not more than that. Whereas in case of Terminologies algorithm, we can definitely run into a scenario where we go on an infinite loop or close to an infinite loop, where we don't arrive at a proper number of clusters or proper results. So that's one of the disadvantage. That's the another disadvantage of the Terminologies algorithm. And the next one is, what happens in Terminologies algorithm is, we start with a random choice for the different clusters, and we arrive at a solution. So depending upon this random choice, depending upon this initial values that we are choosing, the output can differ. For which means that the same algorithm we use on the same exact data set, but the output can be completely different, because we came up with a completely different random choices. So depending upon the choices that we make in the start of the algorithm, the output can completely differ. So it could be the same data set, it could be the same algorithm, but still the outputs can be very different to each other. Whereas that's not the case with the hierarchical clustering. So no matter so there is no random choices that we are making. So no matter what is the data set, we go through the process, it can be agglomerative or divisive approach, whatever it might be, the outputs doesn't change. So these are all the various reasons why Terminologies algorithm is not suitable in some cases. So when we have a data set where the ideal number of clusters are not very intuitive, we are not able to get the ideal number of clusters using the elbow method, and maybe the number of iterations are going on an infinite or a large number of or a huge number of time, huge time is taken for processing it, So in those scenarios, what we can do is we can definitely go for an hierarchical clustering and then see what happens, like how better the results are, like how better the performance time is as compared to an K-means algorithm. So these are all the different scenarios where we need an hierarchical clustering. So moving on to the next one, like the two different types of hierarchical clustering are agglomerative and divisive. So when I take agglomerative approach, it is a bottom-up approach. So what happens is, as you see on my screen, each observation in the dataset is first initially considered as an cluster by itself. So if we have an observation, we consider that there are n different clusters in the dataset, and what we do is we identify two observations that are closer to each other. So what we do is we combine those two observations together into one cluster, and next what we do is we repeat this process. We identify again two different clusters that are closer to each other. So we continue this process until all the observations becomes one cluster. So this is agglomerative approach, which is considered as a bottom-up approach, where we consider each observation as a cluster, start combining each of them together to form a cluster, and we stop only when all the observations are combined into one cluster. The next one is a divisive approach. So it is called as a top-down approach. So here what we do is we do the exact opposite. So we consider there is only one cluster. All the observations are part of one cluster. So then what we do is we divide this into two different clusters that are least similar to each other. And then what we do is we repeat this process. So each cluster is taken, it is divided into two different clusters, and this process continues until we reach n number of clusters, which is nothing but which is equal to n number of observations. So each observation is considered as its own cluster. So only then we stop in case of divisive approach. So the agglomerative approach is simple and it's easy to interpret, and the divisive approach is slightly complex, but the accuracy is proven to be much better, or always better, than agglomerative approach. So these are all the two different types of hierarchical clustering. Moving on to the next one, what are all the steps involved in the hierarchical clustering? So as you see here, in case of agglomerative approach, what we do is we make each observation as a single point cluster. So when there is 10 observation, we consider that there are 10 different clusters in the dataset. So then what we do is we pick two observations that are closer to each other. So when we have two observations that are close enough to each other, we combine them into one cluster, and all the rest observations will be clusters by themselves. So we continue this process. Then what we do is we next identify two different clusters that are close enough to each other, and we combine that into a single cluster. So this process continues until we have only one cluster. As you see, we have only one cluster in the dataset. Now, in case of divisive, so as I explained, so we start with one cluster. All the observations are considered as one cluster. So we divide the observation into two different clusters that are least similar to each other. So once we divide that, what we do is we continue this process. We again partition the cluster that has more than two observations in it, and then divide that into two different clusters that are least similar to each other. This process continues until we have one cluster for each observation that is present in the dataset. So these two approaches are exactly opposite, but it has been proven that the divisive approach, even though it is slightly complex, the performance of the divisive approach seems to be much better, or always better, than the agglomerative. Moving on to the next one. So this is a simple example where we have only one attribute for a small set of data, and then we are going to see how an agglomerative approach would work. So what we have is we have A, B, C, D, and E. So let's consider these as 5 different individuals, and what we have is we have the expense details of all these individuals. So it is like a very small data set, and we have only one attribute or one feature, which is the expense for those individuals. What we are going to do first is we need to come up with the distance matrix. So this is the distance matrix as you see here. So if you see A to B, the distance is 200. That's the difference between A and B. So A to C, the difference is 1.1k. So we calculate the distance matrix for all the observations. So here we have 5 different observations. So we have 5 by 5 matrix where we get the distance of each of those observations to the other observation in the dataset. So then what we do is we first identify two observations that are close enough to each other. So in this case, what we can see is we can clearly see the smallest distance between 2 points in this matrix is 200, which is between A and B. So what we do, we combine A, B together into a cluster. So as you see in the next iteration, A and B are combined together into one cluster, and we can pit any method, like we can pit the max of these two, or we can pit the min of these two, or we can take the average of these 2 points. So in this case, what we are doing is we are going to pick up the max of those 2 points. So here the max of these 2 points is 1.2k, and we are going to use 1.2k. Again, we are going to build the distance matrix. So A, B together is considered as one cluster. Now we are going to identify the distance between AB to C, D and E. And that's how we come up with this particular matrix. And now what we are going to do is we are going to identify the smallest distance. The smallest distance here is 500, which is between C and D. So we combine C and D together into one cluster. So already we have AB, now we have CD, and then E is a separate cluster by itself. So this is the new matrix. So then what we do is we again identify the two different clusters that are close to each other. So here the smallest distance is 1.1k, which is between AB and CD. So we combine them and then we make it as ABCD as one cluster, and then E as another cluster. And then finally, on the final step, what happens is we combine ABCD with E, and then we form one cluster. The whole data set is combined together to form one cluster. So this is an agglomerative approach where we start with n number of clusters. Like we have 5 observations here, so we start with 5 different clusters, and then what we do is we combine 2 observations that are similar to each other, again calculate the distance, we again then find out the smallest distance, and then combine the 2 observations or 2 clusters into one cluster, and then this process continues until we have only one cluster. In case of divisive approach, it will be the exact opposite. We will be having A, B, C, D, E as one cluster, and then we slowly divide into different clusters. So it will be something like this. It will be the exact opposite of what we do in agglomerative, but it is proven that like its performance is much better than the agglomerative approach. So the example is continued here. So if we see a pictorial representation of what we have done, as you see, first initially we had 5 observations here, 5 different clusters. We combined A, B together to form one cluster, and then we combine CD together to form another cluster, and then we combine A, B, C, D to form another cluster, and then finally we combine all of them to form a cluster. So this is how it actually looks visually. So maybe if we try to represent this using an dendrogram, so this is a dendrogram which will be utilized when you are going to implement hierarchical clustering, which is very useful in order to identify the ideal number of clusters. So as you see, first A and B are combined together. So this is the distance. A and B had a distance of around 200. So this is here is 500. C and D had a distance of like approximately 500, and then so that's where like you can see it's aligned with 500. And then AB and CD are combined together to form one cluster, and finally A, B, C, D and E are all combined together into form one cluster. So here this diagram gives us some information about how the different clusters are working, like where are the different clusters, like it helps us to identify the ideal number of cluster. So here we can move this red line like up and down, and then we can evaluate like what should be the ideal number of clusters. So in this case, it shows that it makes a lot of sense to have 3 different clusters, like A, B together, 1 C, D together, and then E separate. And that's why like the dendrogram are useful for like it helps us to identify the number of clusters. In case of k-means algorithm, it might not be as clear as this one. So in case of k-means, like it will, when we use an elbow method, sometimes what happens is in a complex data set, the angle of the elbow might not be clearly visible. It might not be intuitive enough. So it might look like a straight line, like not much of a difference. So in those cases, maybe those data sets, if there is no non-ordinal categorical data, let's say it has all the numerical data or features that can be converted into numerical features that has some kind of a sequence within them, then it makes a lot of sense to go for hierarchical clustering and then come up with clear like different number of clusters. So that's the dendrogram, which is useful to identify the ideal number of clusters in case of hierarchical clustering. The next one is some of the key terminologies that are very specific to hierarchical clustering. So the key terminologies or the distance measure and the linkage criteria. So distance measure, it tells us what is the technique, what is the methodology that we use in order to identify the distance between 2 observations or 2 clusters. One of the most common technique is the Euclidean distance. So Euclidean distance is the measure of the straight line between two observations or 2 points in two different clusters, and that's the most common approach. So you can maybe go with this approach. There are some other methodologies available too, and you can choose any of those methodology to identify or to measure the distance between two different points. The next one is the linkage criteria. So now we know how do we measure it. Like we know like what is the unit that we are going to use in order to measure the distance, or the method that we are going to use in order to measure the distance. But what should be the 2 points? Let's say we have two different clusters. So each of these clusters will have multiple observations within them. So from which point to which point do we need to measure? So that is the linkage criteria. That is very important in case of hierarchical clustering. There are 4 different categories. So the first one is the single linkage, which means that we take the shortest distance between two clusters. So we pick up the shortest distance between the two clusters. So we pick two observations from each clusters that are closest to each other. The next one is the complete leakage. In case of complete leakage, what we do is we identify the longest distance between two clusters. The next one is the average linkage, which is the average distance of each point in a cluster to each points in the another clusters. So depending upon the averages, we measure the distance. So this is quite complex because, like, let's say we have a huge number of observations within each of those clusters, so it becomes very mathematically very intense to calculate the distance. And then the final one is centroid linkage, which means that we have two clusters, we identify the centroid for each of those clusters and measure the distance between the centroid, which makes a lot of sense, which will be close enough to the average. So these two are the key terminologies very specific to hierarchical clustering, which is the distance methodology, like what measure you use in order to identify the distance. The second one is the linkage. What is the technique that we use in order to identify the linkage between the two different clusters? So these are the key terminologies. Now moving on to the next one, the final part for today. What are all the advantages and disadvantages in case of hierarchical clustering? So coming to the advantages first. So unlike k-means, where the number of clusters should be passed on as an input, in case of hierarchical clustering, the dendrogram can come up with an ideal number of clusters quite clearly. In case of k-means, it can go on infinite loop or loop that doesn't end, or like that is highly computationally intense or taking a lot of time. Whereas in case of the hierarchical clustering, the dendrogram can clearly tell us the number of clusters, and the number of iteration can never be more than the number of observations that is present in the data set. So it needs to be the number of observations in the data set or less than that. And the dendrogram, like as I explained, the dendrogram output can help us in clearly coming up with the ideal k value, which in case of k-means algorithm or like other clustering algorithm, slightly tricky. So coming to the disadvantages. So what are all the disadvantages of hierarchical clustering? Hierarchical clustering is not definitely like the most superior algorithm. So it has a lot of drawbacks too. One of the most important drawbacks is it is highly memory intense. We need to identify the distance matrix. So this distance matrix needs to be done each and every single time. Like once we identify a new cluster, we again come up with the distance matrix, and then we repeat this process, and it becomes computationally very intense. So when you have a large number of data set with large number of features, it might not be feasible to calculate the distance matrix, and hence maybe hierarchical clustering might not be most suitable. The second one is it doesn't work with the missing values in the dataset. If your dataset is having a lot of missing data, so definitely hierarchical clustering is not going to work for you. And the last one is if your dataset has non-ordinal categorical data, which means that categorical data which doesn't have any sequence within them. For example, if you have a lot of information such as gender, city, state, and so on, which doesn't have any sequence within them. So they have different categories for each one of those attributes, but there is no distance to identify. Like, for example, individuals from two different states don't have a proper sequence to identify like which should be 1 and 2 later. So those are non-ordinal data set. When we have a lot of non-ordinal categorical data set, so then hierarchical clustering is definitely not the good choice to use. Maybe like even K-means algorithm could not be a good choice, because in both these algorithms we need to identify the distance, and for which we need to have some kind of an hierarchy or sequence within the categorical attributes. So if you have a lot of non-ordinal categorical data, so definitely hierarchical clustering is strictly no, and you can try with different approaches. So that's all the advantages and disadvantages of hierarchical clustering. So that is it for today. I hope you have learned something new today about hierarchical clustering, the different types of hierarchical clustering, what are all the steps involved in it. Later, we even saw a simple example, like how we use agglomerative approach in order to come up with the different clusters. What are all the advantages and disadvantages? How do we identify the ideal K value for hierarchical clustering? So that's all for today, and see you in next session. Bye until then.